Hello and welcome to a new part of Let's Code Advent of Code 2022, and we're gonna continue with day 8. Treetop Treehouse. The expedition comes across a peculiar patch of tall trees all planted carefully in a grid. The elves explain that a previous expedition planted these trees as a reforestation effort. Now they're curious if this would be a good location for a treehouse. Okay, this just points to a Wikipedia article. I think we all know what a treehouse is. First, determine whether there's enough tree cover here to keep a treehouse hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. The elves have already launched a quadcopter to generate a map with the height of each tree. Your puzzle input. For example, each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all of the other trees between it and an edge of the grid are shorter than it. Wait, what? A tree is visible if all of the other trees between it and an edge of the grid are shorter than it. Hold on, what does that mean? Between it and an edge. Okay, so if I have a tree right here, I will have to consider all the trees between it and an edge. So these trees should all be shorter, and this should be shorter, this should be shorter, and these should be shorter than this one. Okay, only consider trees in the same row or column. All of the trees around the edge of the grid are visible, since they are already on the edge. There are no trees to block the view. In this example, that only leaves the interior 9 trees to consider. Okay, the top left 5, this one, is visible from the left and top, because 2 is shorter than 5, 0 is shorter than 5, and 5, 1, 2, 5 is the exact same height as 5, so it's not visible from the right, and nor is it visible from the bottom. I see. With 16 trees visible on the edge and another 5 visible in the interior, a total of 21 trees are visible in this arrangement. Consider your map. How many trees are visible from outside the grid? Wow, that's a big forest we have here. No matter. Sounds straightforward. Let's add day 8. And we're gonna get our puzzle input. And we need to parse this input into a grid-like structure. And I think we're gonna we will have a hash set of tuples usize, and the tree height as values. So we have x and y coordinate tuples as keys and u8 as the value. Let's import from string for forest, and we're gonna split the lines first. We also enumerate it, and when we map it, we already have the index, which would be the y coordinate. And we have a line, and for each line we're gonna get all the characters inside it and enumerate that, map it, and we get the x coordinate and a character. And we're gonna parse the character. How do we parse the character quickly? We convert it to a string and then parse it. This sounds so inefficient, but okay. I guess that's okay. And we get a result type, which we will convert to an option. And instead we're gonna use filter map. And we are gonna use the coordinates somehow. Okay, here we have to preserve the x coordinate. Ah, that's bad. Yeah, okay, we have to map this and get the height and make it x comma height. Actually make it x, y and the height. And we can flat map everything. So this is an iterator of tuples x comma y comma height. Let's make this a tuple already. So now we have like the key in the first position and the height on the second position. That means we can directly collect into a hash map. Okay, so we need to return a self with trees, which is exactly this. And we need to return an OK variant of that. And what is wrong here? Mismatched types. Expected struct, usize, u8, hash set? Oh, no. I want a hash map, of course. Huh. Did this just accept u8 as a random state? Random state. I guess that is allowed for some reason. Okay, we are gonna remove hash set because we don't need that. And what is wrong now? Okay, we're borrowing y here. And we can move y into it. That is fine. Okay, so actually there's no error. This can never fail. So let's make the error type infallible. Infallible is an enum that can never be constructed. All right, and we can test this. Let me derive debug on this real quick and then write a test function. Part 1. Print line debug print. Let's create a variable. Input.parse into a forest and wrap it, and then print forest. We can see a lot of data, which is to be expected. Okay, so now that's done. Let's implement some functions on forest. We need a function called isVisible, and it takes an immutable reference to self and the position, and it will return a boolean. And I feel like we need to create a type for the position. I don't want to write out usize every time I need to use the position. Okay, this we need to write. I think we can already deconstruct x and y from this. And let's first get the height. Trees get x comma y, and then we have to unwrap it. But if it's not in there, we just assume it's 0. Oh, consider borrowing. Wait, what? Oh, we have an option of... Okay, we can make it copied, so we don't need to borrow it. Height is now a new 8. Yeah, if the data is not in our tree's hash map, then we assume the tree has height 0. And what does it mean for the tree to be visible? So first we need to go from the left. So let's iterate from 0 to x. And we need to map x to, let's make it filter map. We need to trees get x comma y, and this would be an iterator of the heights, and this would be visible if all of them are smaller than height. Okay, this is a bad naming, so let's name this h. So if all of the trees between the given tree and the very left tree is smaller than the height of the tree we're looking for. Okay. Then it is visible. And also the same needs to be applied for the y coordinate. So let me copy this real quick. So in this case, we get a y, and we can do that. Actually, why don't we avoid copying this code? So let me just construct all the positions that we need to check. So we need to check x comma y. And also let's chain that with 0 to y, map y x comma y. Let's change that. So this is then an iterator of all the positions that we need to check, and we can apply this filter map on it. And they're all predicate. Oh, a filter map is now, we get a position, and I have to put a position in here. So, but this will only check all the trees between, all the trees between the left border and the tree, and from the top border to the tree. So we need to add more. So we have to chain more stuff to it. What we also need to check is y plus 1 till the end. And we also need to check x plus 1 to the end. So if I don't specify the end here, then the iterator will be infinite. It will keep generating more numbers because, there are infinite number of numbers. So we have to end the iterator somehow. And to end it, I think we can make the iterator cancel by adding a take while predicate. So position, and we take while self.trees contains key pos. We don't need the reference here. And the same we will add to this infinite iterator. So when we add take while, this infinite iterator will become finite, and it will cancel whenever this condition does not hold anymore. All right, let's try it out. So for the number, we can simply say forest.trees.keys, and then we will filter out all the positions that are visible. So forest.isVisible pos. Position is a double reference already. Okay, so we will filter out all the positions that are visible and count them. And this should be our solution. Yeah, it doesn't like the double reference, so we'll remove one reference. Oh, is visible doesn't want a reference for position. We'll just remove both of the references. Yes. Zero? Okay, there's definitely something wrong with my logic here. Wait. Okay, I have no idea what's going on. Let's debug this by printing out what happens if I say forest.isVisible 0, 0. It's on the edge, so it has to be visible. It's not visible. Hold on, let me look at the instructions again. A tree is visible if all of the other trees between it and an edge of the grid are shorter than it. Right, not all the directions should be... The tree should not be visible from all the direction. There should exist one direction where it is visible from. Okay, then this won't work. So this means we need to apply this to all the 4 directions. So this direction, and then chain them with an OR. Like this. So we need to check all the directions separately. I think there's no other way around it. Okay, now 0, 0 is visible and our solution would be 2243. That's not the right answer, it's too high. Huh. Okay, something's wrong here. How about we take our test example and run that. 19, which is not correct at all. How in the blazes is 19 the correct answer? Oh, you know what? This is wrong. So we want to iterate over like x values, and I'm specifying the variable here as y. So that was my fault. Now 21 is the right answer for our test input. Let's put it back like this. Now this should be correct. 1845. Yes. Before we move on to part 2, let's make this look nicer, shall we? I don't want to repeat all this code. Let me think how to simplify it. I suppose we can make an array of iterators. And then calling into iter on that. And we use any iterator. If any of the iterator satisfies this condition, then it's fine. Now this is a problem because all these iterators have a different type. Because this is now another closure. Oh, oops, I forgot the cancellation condition. This one. Yeah, all of them have the different types, so they can't be put into an array. Huh. This is bad. We have to write a macro for this? Really? Is that what we need to do? Well, we could all wrap this into boxed trait objects. But do I really want that? I guess I could write a function. Let's call this check height. And we will take an iterator of item that looks like position. And we also need to give it the height, which is a U8. And it will return a boolean. And all this does is iter, like the condition. Oh, we also need to give it self. We need to give it forest, which is a forest. And then we can say, instead of an array, we can say check height. And then put in the OR condition. And then, of course, we also need to give it the forest and also the height. The height. Oh, I need to give it a reference of forest, of course. Still 1848. This just looks so bad though. But I think I can't simplify it further. I mean, if I use a closure to capture the height and the forest in the environment, then I cannot use generics anymore. I could use trait references. I could use trait objects. Shall we use trait objects? I don't think performance is a problem here, so we can use trait objects. So let's make it a closure so that we can capture the variables. And of course, we need to pass in a mutable reference of the iterator. Same for these ones. This still works. It looks much nicer now. So I count that as a win. Let's move on to part 2. Content with the amount of tree cover available, the elves just need to know the best spot to build their tree house. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left and right from that tree. Stop if you reach an edge, or at the first tree that is the same height or taller than the tree under consideration. If a tree is right on the edge, at least one of its viewing distances will be 0. The elves don't care about distant trees taller than those found by the rules above. The proposed tree house has a large eaves to keep it dry. What are eaves? The roof overhang, okay. So they wouldn't be able to see higher than the tree house anyway. In the example above, consider the middle 5 in the second row. Looking up, its view is not blocked, so it can see one tree. Looking left, it cannot see. Its view is blocked immediately. It can only see one tree. Okay, this also counts. Looking right, there are 2 trees visible. Looking down, there's also 2 trees visible. A tree's scenic score is found by multiplying together its viewing distance in each of the 4 directions. Okay, what a weird score. However, you can do even better. Consider the tree of height 5. this tree's scenic score is 8. This is the ideal spot for the tree house. What is the highest scenic score possible for any tree? Alright, this is a little bit more difficult, but it should work the same as part 1. Let's add a new function for the scenic score, which also takes a position, and it will return U64. Let's also get the height first. So there's still 4 directions, and let's make it for one direction first. So we look to the left, so this is 0 to x, but we need to reverse it. So it's from x to 0, and then we take while. Okay, we need to map it into a position first. So x comma y. And we will take while the position, take while self.trace get position. Pause is a reference already. So take while when we get it. We get the height. And the height needs to be smaller or equals height now. Because if it's the same height, take while. If it's the same height, we can still see it. Actually, we need to take while age is smaller than height. Because if it's equal than the height, then we need to stop already. So this is the correct condition. But we need to remember that this is bad. This is bad because if we count trees here now, we may be missing the final tree, which is equal to the height itself. Oh, this is tricky. Let's filter first. Filter map. What we want is self.trees get position. So now this is an iterator of heights. And let's think about heights. Take while h is smaller or equals than the height. That's what we had before. This is exactly the logic that we had before. Okay, you know what? I've thought about this a long time and I don't see an easy solution. So we have to take while the height is smaller than height, not equal to height. And when the iterator stops, we need to check one more time if the tree where we stopped is of the same height or not. And depending on that, we need to add 1 to our count. It's a little bit crazy. So let me also introduce a check height function closure for our scenic score method. We would need iter.filterMap. Take while age is properly smaller than height, and then get the count. So this will actually return me a U size. We want to count the tree, so let's call this count trees maybe. Let result equals that. And then we would say if iter.next if let sum final item equals iter.next, and if, and final is a height, no, final is is a use size. Okay, this is bad. Let me add a temporary variable here. I have no idea for the name. Let's call it iter2. That's really bad, but let's just do that. I want iter2 to be this. And then we can say iter2 take while. And then iter2 next. Final would be a u8. Oh, I cannot use final. Okay, let's say final height. If final height is equal to height, then we would return result +1, or we would add 1 to result. Let's make result mutable for that, and we will return result. Okay, we iter2 should be mutable. Iter2 is moved due to this method call. Take while will consume iter2, but let's do the usual trick by calling take while on the mutable reference on iter2. So the iter2 would not be consumed. So iter2 will actually is an iterator of the heights. So let's call it the height iter. Okay, so now we would need to call count trees on 0 to x, reversed, map, and that's it. Then let's call this left trees count, and we have to give it a mutable reference of an iterator. Okay, for top trees count, this would be similar. We'll just make it an iterator from 0 to y and map y to x, y. Now for right trees count, it's a little bit more difficult. We would need the same iterator that we have here and use the take while to make this a finite iterator. And last but not least, we have the bottom trees count, which would exactly be this iterator. And in the end, we will, this is a U size, so let me return a U size. In the end, we need to multiply everything for some reason. And that's it. Let's try it out, shall we? I don't feel too good about this, but let's see. We have the forest. And all we need to do is... What do we need to do with the scenic score? What is the highest scenic score possible for any tree? Okay, so we would need to... iterator over all the trees again, and we need to map all the trees to its scenic score, I mean. Pause is a reference, so we remove that reference. So we have an iterator of scenic scores, and we want the highest one and wrap it. $201,348. My answer is too low. No, my answer is too low. Let's check the count trees logic again. Oh, wait. when take while ends, like take while checks the heights if it satisfies this condition. And when it ends, it's already on the final one and it consumed the final one already. That's what's going on here, isn't it? This is more complicated than I thought. Yeah, in this example, we have an array, we iterate, and we say take while n is not equals 3. So it only returns 1, 2, right? But if we collect the iter again, then we only get 4 because 3 is already consumed as well. Oh boy! Oh boy, and I did not realize that there's a byref function. Iterator has a byref method. What does it do? Borrows an iterator rather than consuming it. Oh hey, I could have used this function, this method all along. Never mind. How do I solve this dilemma? I have no clue. I thought we could maybe do this the iterator way, like not allocate any vegs, but I suppose this doesn't work. I can't think of any way to do this without having access to the next item. You know what? Let's make it a vec. Collect into a vec. And then everything should be much easier. So we would heights.iter. And we don't even need that. We have to enumerate those so we get an index. So we have I, h. Take while h is smaller. Height. Actually, we don't even need enumerate. What am I doing? And then use the count. And we can use the count as an index again for heights. So yeah, let's make result mutable as well. And then we just need to check heights get result. That's interesting. Using result as an index if let sum final height equals that. If final height equals height, then we would add 1 to result. Final height is a reference, so let's eliminate it. Okay, so this should work. This is now correct. Yes! Holy crap. Okay, I couldn't find an answer, a solution to this problem using iterator only, which is a shame actually. I thought, definitely feels like it should be possible. Write it down in the comments if you have a solution that does not involve collecting everything into a vec. Yeah. And does not involve, implementing a custom iterator for that. Using only iterator helper methods. Can we solve this actually? Write down in the comments if you have any idea. If you enjoyed this, as usual, like and subscribe for more for the days to come. Bye!